Good afternoon, everyone. My name is John Lim, and this presentation is for tuning your data engine, how packs and forks supercharge value. Who am I? My name is John. I'm a lead systems engineer for Cox Automotive. I've had 10 years of experience for data pipelining, visualization, and reporting with both Cribl Stream and Splunk. I'm also passionate about technology process and operationalization. So being able to create repeatable process that enables technology is definitely something that I'm looking to share with the audience in this particular presentation. What is our agenda today? First, we want to discover or know your company's adoption challenges. We need to understand what is the problem we're facing, what are we looking to solve when we're trying to tune a company's data engine? What are we looking to do with packs? How are we looking to leverage forks in order to gain value? So that's step one. Step two would be to identify targets. What does that mean? Data sets are plentiful. So it's important to create a priority list when you are adopting Cribl Stream and creating pipelines and implementing packs. The third step that I would like to talk about is establishing the process. As I mentioned earlier, I'm passionate about process and operationalization. So a life cycle for this process is important. It has to be repeatable and modularized so that it can be time boxed and iterative. And finally, I would like to talk about documentation and how important it is and what should be in it so that your process can be successful long term. Okay, so why is high velocity adoption needed? So most IT companies are always budget constrained. Most of our leaders are looking to get more value out of the same budget. So the data growth CAGR, which is the growth of data, is usually on a parabolic graph. As you can see here, it's rising at a steady pace and usually exponentially. Data value, on the other hand, tends to increase very quickly, but then kind of stops, right? So I think that the intersection here on the right hand side is where most companies find themselves at a crossroads because the more data there is, the data management complexity increases, the amount of technical debt increases, and companies find themselves having to look for solutions to solve for finding what matters. You know, what data is important, how can we get there, what tools can we use to make sure that happens. And of course, the little orange line at the bottom, which is the IT budget growth, is not exponential. I think that everyone can relate to that. And so we have a challenge on our hands. Now, obviously, Cribl Stream is a fantastic tool. Everyone here is familiar with it to a certain extent. I'm not here specifically to talk about the technical abilities of the tool, but I am here to talk about the adoption challenges when it comes to Cribl Stream. So when you are introducing Cribl Stream to your company, there's typically common points of friction. So number one, there is the legacy state of your data. So existing methodologies of data ingestion, processing, and output, they already exist. There may be existing technical debt. There may be data pipelines that you're not fully satisfied with. Maybe it's not providing the key value pairs that you want. So all of that will have to be revisited. Unfortunately, even quote unquote bad data onboarding has objects behind it, that whether that be observability objects or security objects within Splunk. When it as you move towards onboarding your data, what ends up happening is that solutions are created on the front end. So a basic example of this is somebody used regex to create a field because the data underlying was not satisfactory. You know, it didn't extract the key value pairs. So when you change that data, the data stream and you generate those key value pairs, now you have created technical debt in terms of a regex. So one of the solutions for that, we'll go over that a little bit later, is to make sure that there is a fork so that both the old and the new data set can be evaluated. That segues nicely into the next challenge, which is the reliance on current data. How will you handle downstream knowledge objects, right? So if there has been a reliance, I'll use Splunk as an example at search time. If you're creating fields at search time, then you are using the underlying data as is. So now if you fix that data, you make any changes to that data, you may be impacting downstream knowledge objects. And finally, there is the data attribution. Are your data sets properly tagged prior to ingestion? How do you know who owns each data set? Before you go changing data sets, you need to know who owns it. Typically, this issue is solved through knowing, at the very least, which of your data is security specific and which of your data is observability specific. So some investigation will be required for data attribution to at least begin to understand data set targeting. Now, before we move on, I wanted to share this quote by Piet Hein, who is a Danish polymath. Problems worthy of attack prove their worth by fighting back. Now, from my experience at Cox Automotive, none of this is easy. It's very important to target these data sets very deliberately. The issue typically is that this data is owned by a lot of different teams, and you have to establish relationships with them and inform them exactly of what you're going to do when you cut over their data to Cribl stream. So typically this is where there's a human element to the friction. So that's what we're looking to overcome. Okay. Moving on, I wanted to talk about one of the first steps of the linear process for the iterative adoption of Cribl stream, which is data set targeting. So obviously, a lot of us here, we have so much data, right? So much data. What should I target first? So in our experience, there are 3 types of data that you can cut over to Cribl stream, where you can have Cribl stream assist in improving data quality or reducing ingestion. One of them is, the first one is tow-in. Tow-in typically represents around, give or take 10% of your total data volume. These are custom data for specific use cases. So think small applications. If it's a custom app that uses Python and just is a basic app, it generates a very little amount of logs. It won't, it's not like syslog where it generates a ton of logs. So what does that mean? So it's tow-in because the impact isn't as large as cutting over a high impact data set. So that's the positive. The negative, obviously, is you won't be making as much impact. You're essentially testing the waters, doing a tow-in of Cribl stream, and essentially creating value through the tow-in. It's not meant to greatly reduce your ingest, right? So the second data set to target would be problematic data sets. We all have data quality issues. So those data sets are typically non-structured. So, think single line logs or custom application logs that have a stack trace or things like that. So what you're looking to do is to fix specific problems with parsing. So that would be key value pairs. The timestamp is wrong, the line breaks are wrong, the aggregation isn't working properly. So those are the problematic data sets. From our experience, that's around 20% of the entire data set available to the company. So that brings us to the last one, which is where you would make the most impact, which is, appropriately named high impact data sets. So these are typically large data sets like something in the network space for syslog. So some good examples of that are Cisco, Palo Alto, etc. There are usually packs available already created by Stream, recommended for your team to use and evaluate. So those are the three different types of data sets that could be targeted for this process. So now let's talk about the process. So what does this process entail? So we just talked about targeting, right? So the first thing to do is to pick a target data set and evaluate existing methodologies. So I'm going to use Cisco as an example, and I'm going to use that throughout the rest of this presentation. So most companies have Cisco ASA, which is Adaptive Security Appliance Logs, and Firewall Threat Defense Logs, called FTD. So these typically come in all through syslog, right? These two data sets are good targets because they fall under the high impact group of data sets, meaning there are typically a lot of these devices and they send a lot of logs through system logging. So they are a good target for reduction and for cleaning. Now, the second step here is to identify the Cribl stream pack to use. Now, fortunately, both ASA and FTD for Cisco have out-of-the-box packs already from Cribl stream, which means you can implement them right away. There's no building required. You just send the data through the pack, make sure that everything is good, and you send it to whatever destination that you want. Now, just because you can do it doesn't mean you should just cut over right away. So the next step here is to fork the data. So what you want to do is use Cribl Stream's capabilities to send data to multiple places, to fork the data to at least 2 unique destinations for evaluation and minimize the downstream impact. You will also be able to identify what sort of impact you'll be creating, because you can now compare 2 data sets side by side, see the differences. Did I rename a key value pair? Do I need to fix that? Right? So you'll be able to compare that along with your stakeholders, who you can now show a forked data, kind of think of it like a preview. It's like, hey, this is what your data will look like after the cutover. Let's make sure that everything is good with you, the way you search the data, and also the objects behind it, wherever those objects are. It doesn't necessarily just have to be Splunk. It could be objects, any object that uses that data just has to be evaluated and approved by the stakeholder. So that segues into evaluate, which is working with the customer to review data format changes and clone modify existing knowledge objects. So the evaluation process to me is the most important. This is where you get buy-in from your customer. And the great thing about it is that while this is all being done, there are no interruptions, right? I mean, it's business as usual. You just have an extra data pipeline sending to a different place where you and your stakeholders can evaluate the data before you do a final cutover. And finally, that leads us to the last step, which is the cutover. So switch to the new and improved data stream after everything is approved, and then turn off the legacy data stream. So let's talk more about that from a technical perspective. How does that all work? So let's start with target. So target in this case, as we discussed, is Cisco syslog. So that's Firewall Threat Defense and Adaptive Security Appliance Logs. So why was this selected? As mentioned earlier, this is considered a high impact data set, which has a lot of logs depending on the number of devices you have. Experience may vary depending on just how many just how many hosts are in your environment, how many firewall threat defense logs you have, and how many ASAs you have, right? In our case, we identified this as a good target because there was fairly significant _raw reduction, which means that we're sending less data to the destination, which means we're saving money, right? So, and the pack also gives us the capability of retaining only the required fields and suppress any noisy messages or codes that the stakeholder doesn't need. Since you are properly parsing key value pairs using the pipeline, you can then take that to your evaluation with the stakeholder and say, hey, do you need all of these info logs? Maybe you don't need certain codes, you're not interested in them. In this case, our customer was security. So there was only specific codes that security was interested in. So I work with one of the security engineers to identify which of those are, and we can just simply drop the pieces of data that are not needed. So that saves us even more ingestion. So that's targeting. What about forking? What does that mean? So when we say fork, that means send a separate data stream, usually a clone, right? So when you do a fork, you you keep one version of the data unaltered, send it to the original destination, and make sure that it arrives to the destination the exact same way that the stakeholder is used to it previously when you started this process. Now, the second copy of the data can now be sent through the pack, and changes can be made, and the review with the stakeholder can be done with no impact to the business. So for forks, there's a couple of options. When during the evaluation phase, you send data to the original destination, one copy, and then the other copy you send through the pack, so that the pack's data can be evaluated against the original data. So 2 copies. Once the evaluation is complete, we simply flip the original copy, unaltered copy of the syslog, and we normally send it to an S3. So why is that? Right. So number one, S3 is cheaper storage. Number two, if a deep dive is required, and for whatever reason, any of those codes or those logs that we drop are needed for investigation, they will be available long term in a very cheap place. Or it doesn't even have to be S3. It can be anywhere that you want that's considered cheap storage. A storage for Splunk, for example, is not considered cheap storage, so we don't send it there. So we send it to one of those long-term storage options. Okay, so that is fork. The next step is evaluate. Now, this is where it's important to get the stakeholders' approval, make sure that relationship is solid, that enough time is allocated to the evaluation process. For us, it was around 2 weeks. That we were looking at this pack and what it does along with our security team, and make sure that, hey, that this doesn't impact any downstream security models that occur, or if any changes need to be made to the existing security model. Let's say they were doing regex on a search, then we've already accounted for that, for those changes. So that is the evaluation process. Use the fork to present a new version of the data while keeping the original version of the data intact for business, and obtain feedback and make any adjustments needed to the pipeline and the pack. Of course, working with the stakeholder, it depends also on how many objects they have downstream. Those will definitely have to be looked at if they use this data set. So there's a lot to do in this phase, and so we recommend, this is the longest part of the process. So after a couple of weeks, everyone's happy. We have all the key value pairs that we want. We've already accounted for the data models or the searches, saved searches, anything like that. We've created possibly aliases in Splunk to account for any differences in key value pairs, that sort of activity. So once all of that is good, the final step is the cutover. So the cutover just simply means that the final route will be going through the pack. So this means that let's isolate the ASA data and the FTD data, if it hasn't been already, and send it through the respective packs that was pre-approved by the stakeholder. And then we convert the other data stream. If we remember earlier, there was an original unaltered Cisco syslog data stream. We send that to our long-term storage or wherever we can store it cheaply. How does that now all come together? So this should be an iterative cycle. So that brings us to the data engine. So the data engine is building your Cribl stream migration process that you are implementing on a dataset by dataset basis into a continuous life cycle until you're done. So we're just bringing together all of the steps. So step one is pick your target and identifying the correct pack, right? So that's always step one. Pick your target data set, whether that's a tow-in data set, problematic data set, or a high-volume data set. You pick one, and you evaluate the existing onboarding methodologies, right? Is it going through Universal Forwarder? Is it going through syslog? What is it? Because to create a fork for that data set, that data needs to be sent to Cribl stream. So that solutioning needs to be done, and then send that data to Cribl stream. So you have an unaltered data stream. The next step is to do the fork, which means you need a second data stream that goes through the fork, which we explained the process of forking earlier. Fork the data to two unique destinations for evaluation and minimize the downstream impact. Work with the customer to review data format changes and clone and modify any existing knowledge objects if needed. So that's a summarization of the fork and evaluate process from earlier. Number 3, of course, is to cut over, switch to the new and improved data stream, the new and improved Cribl stream data pipeline by turning off the legacy data stream. So once everything is approved and the stakeholder is happy, the cutover happens and the new data stream is operationalized. And step 4, finally, is what we didn't discuss earlier. So step 4 takes us into the loop. So once the cutover is done for data set A, it's time to evaluate data set B. So this enables an organization to chunk their adoption. So what that means is you put in this iterative data engine process, and you can attack data sets one by one versus kind of being overwhelmed by the sheer amount of data that exists. So use targeting from your inventory of data to start cutting things over the stream, depending on the kind of value that you want to realize, or if you're solving for problems, or you just want to prove the capability of the tool to an app team. So there's multiple avenues in which to perform adoption. Okay, with all that being said, I would like to take a slide to really enforce the fact that iterating requires documentation. Each new migration must be documented and reviewed. So iterate for scale. Every data set migration can be unique because there's different data onboarding processes, there's different types of stakeholders, there's different types of needs for that data. So a well-written process can be handed off to multiple engineers to execute at scale. So what does that mean? So if you wrote a process to perform this data lifecycle evaluation for, let's say, universal forwarders, you have a document for that. Syslog, you have a document for that. If it's a modular input, like a TA or on a heavy forwarder, you can have a document for that. What we've found is that engineers can typically handle one end-to-end migration per 2-week sprint. So this allows you to pass that along to operational engineers instead of having, hey, only 2 people know how to do this, right? So the idea is to make sure you have a process so that folks on the team can learn and everybody on the team can do one of these a sprint, or stick to a schedule. Let's say, hey, we're going to do a couple of tow-ins this sprint, but next sprint we're going to attack some problematic data sets. Now you can keep a schedule because you know that all your engineers have a process to follow. So that brings us to document thoroughly, right? Both the process and the information about the migration itself must be documented. So there are unique migrations, but some of them can be similar. So what does that mean? So for example, Cisco and Palo Alto are both syslog sources. So a lot of that data onboarding is pretty similar. So when it comes to sending that data to stream, to Cribl stream, then they would not be that different. It would split in terms of evaluating the pack and things like that. And the key value pairs are obviously different, but the data onboarding process and how it flows, syslog is syslog. So that will help to have documented thoroughly. The other important thing, of course, is customers must be identified. The process must have a section where, hey, you must identify a customer and the stakeholders. And again, as I mentioned earlier, security is usually a nice common thread to follow. It's like, hey, work with security because it's a Palo Alto log, because it's Cisco ASA log. And finally, Establish a customer cadence. Quarterly is recommended, but can be limited to when a change in data pattern is detected. So, what does that mean? Data is not static, right? Data is going to change. So, this document will actually enable you to track your data sets so that if anything changes with them, you know who owns them, you know who the stakeholders are. Um, as an example, one of our applications here went from on-premise to AWS, and yeah, our pipeline was not working as expected. So that change, when it occurred, we were alerted to a change in the data, and we went to the customer and said, hey, what's going on? And we used the documentation that we had in place because we had a label, right? So this data is owned by this team. So we were able to approach that app team and say, hey, did you make an architectural change? And it turns out they did. So now we could go back to them and say, hey, so we have to make an adjustment to your pipeline to make sure that your data set is healthy and the data quality is good. Okay. And I would like to share this quote by a Mr. Sam Hinkie, American basketball executive, who says, trust the process. So, from an operational enthusiast perspective, I've always tried to trust the process, especially if it is a peer-reviewed process, and the data engine lifecycle is definitely one of those processes that has been tested quite a few times. This is how we're adopting Cribl Stream across the enterprise, one data set at a time. I would like to thank everyone for listening to this talk, and it is much appreciated, and hopefully everyone took something away from this. Thank you.